Okay, I'm doing the 2017 paper, so let's just quickly go through this. Okay, so we have a uranium that splits into an alpha particle and thorium. In the beginning, it is stationary, so one's going to the left, one's going to the right because of conservation of momentum. So here you got 238 is equal to 234 plus 4, and then 92 is equal to 90 plus 2. So here the 234 should be thorium, but if you don't know the element, you can still write down X. So here you got 238 is equal to 234 plus 4, 92 is equal to 90 plus 2. Remember, the alpha is 42. The alpha particle is 42. Here, for this question, look up the alpha particle mass in the datasheet. Just remember the equations. P squared is equal to 2m times kinetic energy. And for this question, you need to use the conservation of momentum. So the sum of the momentum before the collision is equal to the sum of the momentum after the collision. And then you can use P squared is equal to 2m times the kinetic energy. It's asking you for the kinetic energy in mega electron volts. Don't forget to divide by 1.6 times 10 to the minus 19 to convert joules into electron volts. For this question, you need to use a bit of algebra. So 238, 92 uranium is equal to alpha, 42 alpha times A plus the electrons times B plus 20682 lead. Now, because you don't know how many alpha particles there are, you don't know how many electrons there are, that's why I put A and B there. And then you solve the simultaneous. For this question, you need to use three equations here. So F is equal to Bev, F is equal to the electric field strength times the charge, and the voltage over distance gives you electric field strength. You're combining all three equations together. For this question, use the equation I equals nave, rearranging for V to give you the answer. This one uses the equation that we worked out in the first part. For this question, V is too small to measure. It is very difficult. So the question will suggest one reason why this Hall probe is not suitable instrument. For this question, F is equal to Bill, rearrange for B. F can be found using a weighing scale. Plot a graph of F against I to find the gradient, which is BL, and then because you want to work out B, that is the gradient divided by L. If L is small, uncertainty is large. For this question, you ln both sides, so ln v equals ln v naught minus t of rc. You compare with y equals mx plus c, and in the question you're given that t is 15, so put that in. For this question, you need to ln 3, so ln 3 to do decimal places. Remember, because in the data sheet, in the table, you're given 2 decimal places, and then to work out ln. To work out the error for ln, you do the absolute uncertainty divided by the actual value. So in this case, you got 0.2 divided by 3. This should say 0.066, and round it up, that gives you 0.07. For this question, for the next question, so you do the line of best fit, you work out the gradient is 15 over c, rearranging for c, you get gradient over 15. Then you work out the line of the worst fit. So you need to do the top of the error bar on one side to the bottom of the error bar on the other side. Work out C. Now you should have two values for C. To work out the absolute uncertainty, you take the two values of C from each other, and then that will give you the absolute uncertainty. For this question, you're given 10%, which is 0.1. So V is equal to V naught e to the minus t of RC. You want to work out R. For C, you've worked that out in a previous question. So you just substitute all those values in. I'm just going to skip this question for now. Okay, so for this question, you need to read off the graph. So you need to read off the graph. It says 0.8 watts per meter squared. Once you've read off the graph, that is 3 kilo ohms. And then you use the equation V equals IR. So in this case, you want to rearrange for I. So I equals 4 volts divided by 3 kilo ohms. That gives you the current is 1.33. Why do you do 6 minus 4? Because you want to work out the voltage of the other component, because the EMF is 6. So 6 minus 4 is 2. And then you do 2 divided by 1.33 milliamps. That gives you 1,500. And then here, because in the previous part it's 4 volts, now it is 2.4 volts, because which is the lamp switches off. So now you have 2.4 volts across XY. You do the remaining voltage, so that gives you 3.6, and then you use ratios. 3.6 over 1500 equals 2.4 over R. Work out what R is, and then you look at the graph. This gives you about 2.4 to 2.5. Okay, for this question, you need to know that from compression to compression is one wavelength, and then because it's C to R, that gives you 1.5 wavelengths. So you need to draw 1.5 wavelengths. X and Y is the maximum gradient, because this gives you mark one point where the air particles are moving at a maximum speed. Maximum speed is when the displacement is, the rate of displacement is maximum. Here, mark one point where the air particles are moving at maximum speed and then traveling in the opposite direction. So here you do X and Y. They have to be consecutive, X and Y. For the next bit, you do V equals A omega. So the amplitude is 2 micrometers. And then you're given, in a question, you're given the frequency, and omega equals 2 pi f. So omega is 2 pi f, just substitute all those values in. For the next question, you use 3 over 2 kT equals half mc squared. Convert the temperature into absolute Kelvin scale. That gives you 290 Kelvin, and then just put all the numbers in. And then you need to work out the square root of c squared, because it's asking you for the root mean square. For the next question, talk about coherence, talk about interference, talk about reflecting off one edge or the boundary. Node to node is lambda over 2. Mention the equation V equals F lambda. Talk about antinodes and nodes. V is the same. To reduce uncertainty, because lambda can be quite large, you want to reduce F. So that's how you reduce percentage uncertainty. And then why would you do the experiment inside? Is because you want to have less reflections. More reflections with the walls will interfere with your experiment. And then I think one more question. Okay, so this question, you need to label the weight. You just need to label the other forces. In this case, it's the weight. Here you're resolving, so you've got T cos theta equals the weight, so this is the vertical component, and then the horizontal component is the T sine theta equals mr omega squared, or mv squared of r. Use simultaneous, and then you get theta equals 22. For this question, you need to use F equals kx, mg equals kx, and then rearranging, you also need to use T equals mg over cos theta. For this question, you need to use the equations S equals ut plus half at squared. Work out the time. Once you have the time in the vertical components, you can work out the time in the horizontal. And then once you have that, you can use Pythagoras. Because if you look at the diagram, you need to use Pythagoras here. Returning to the situation, state and explain what happens when the rate of the rotation of the ball is increased. T increases, this gives you a bigger centripetal force.